Proof by vector method. Proof by vector method that the line joining the midpoint of two sides of a triangle is parallel to third side and half of its length. At first we have to make a triangle. Make a triangle A, B and C. P and Q are midpoint of this AB and AC. It means given in triangle ABC, P and Q are midpoints of sides AB and BC respectively. To prove we have to prove that P cube is equal to 1 by 2 of BC and P cube is parallel to BC. P cube is parallel to BC. It means in this figure we have to prove that P cube is, this line P cube is parallel to BC and P cube is equal to half of BC. Proof. At first take PQ vector is equal to PA plus A cube by triangle law of vector addition. After that PA means half of BA and AQ, this A cube is half of AC. AQ is half of AC because P and Q are midpoint of AB and AC. Similarly, now take here 1 by 2 is here, 1 by 2 is here, so take 1 by 2 is common, then what remain? BA vector plus AC vector. BA plus AC, see that figure, BA vector plus AC vector is equal to BC vector. It means PQ vector is parallel to BC vector. By statement 1 P cube is equal to P cube is parallel to BC. By statement 1 P cube is 1 by 2 of BC. It means here first part is here proved first part and then here proved second part. Now question arises, how you know that P cube is parallel to BC? Here is given just equal. Here is given just P cube is equal to 1 by 2 of BC. We know that one vector is equal to scalar multiplication of other vector. It means they are parallel vector. Similarly, this 1 by 2 is here scalar multiplication. It means P cube is equal to scalar multiplication times BC. So P cube is parallel to BC. Now let's move on next theorem. It means this theorem is proved. Now next theorem. Prove vectorically that the midpoint of hypotenuse of a right angle triangle is equidistant from its vertices. It means at first we have to draw a right angle triangle ABC and take M is midpoint of AC. It means AC is hypotenuse here, so take M is midpoint of AC and then join B to M and then join B to M. Now given in right angle triangle ABC, right angle at B and M is midpoint of AC. It means this part is given. And then to prove AM, this AM is equal to MC is equal to bm, but m is midpoint, it means am is equal to mc already is given equal. It means now only remains we have to prove this bm is equal to mc or bm is equal to am. Let's prove first. At first take ab into bc, ab vector into bc vector is equal to 0 because ab is perpendicular to bc. When one vector is perpendicular to other vector, when one vector is perpendicular to other vector, their scalar multiplication is always 0. So here AB vector into BC vector is equal to 0. Next, or AB vector, see that AB is equal to what? AM plus MB, triangle law of vector addition. Similarly BC, this BC is equal to BM plus MC, that is equal to 0. Now again AM, here AM remains same, plus BMB, MB is remains same. This BM is changed into minus times MB plus AM. This MC is changed into AM because this MC and AM are equal, they have same direction and then their magnitude are also equal. Now AM plus MB is equal to AM minus MB. Now see, AM plus MB, AM minus MB, it is formula of A square minus B square. So MB square minus BM square is equal to 0. We know that if a square is there, that will be changed into scalar, so no need to give sign here. If you give sign, then also no problem. Now we can say that AM square equal to MB square. Now square and square cancel, AM is equal to MB, hence AM is equal to MB equal to MC. Proved. Next question, prove vectorically that the line joining the vertex and midpoint of base of an isosceles triangle is perpendicular to the base. It means, according to the statement, line joining the vertex and midpoint of base of an isosceles triangle is perpendicular to the base. It means this ABC is an isosceles triangle and D is midpoint of BC. We have proved that this line AD is perpendicular to BC. At first given. Triangle ABC is an isosceles triangle in which AB is equal to AC and then D is midpoint of BC. To prove AD is perpendicular to BC, this line AD is perpendicular to BC. Now proof. At first take BC vector into AD vector. BC into AD. This BC vector into AD vector. Now why we are taking BC into AD? If BC into AD, that result will be 0, then our if BC into AD is equal to 0, then we can say that AD is perpendicular to BC. So we are taking BC into AD. Now BC means BA. This BC vector means BA plus AC. BA plus AC. Similarly, AD vector means AD vector means AB plus AC by 2 by using midpoint theorem. That part is here. It means BC is equal to BA plus AC and AD is equal to this AB plus AC by 2 by using midpoint theorem. Now next, BA means this BA vector means minus AB vector, and then this plus is remain same, and then AC is also remain same, and then AB plus AC by 2, AB plus AC by 2, that is also remain same. Now make it, this AC is here, and then minus AB is here, and then AB plus AC by 2. Now see this AC minus AB, and then here AC plus AB. It means it is formula of A square minus B square. Then we can say that this one is AC square minus AB square. But see here, AC and AB are equal. AC and AB are equal because that is an isosceles triangle. Two sides will be equal. So here AB and AC are equal. It means this AB and AC and AB are equal. Now replace AC square minus AC square, because this AC is equal to AB. In the place of AB we can write AC. Now AC square cancel, 0 by 2, that is equal to 0. It means here product of BC and AD is equal to 0. Now we can say that AD is perpendicular to BC, proved.